This is lesson 10, applications of quadratic equations. So now we're going to look at how we can apply these quadratic equations. So a ball is thrown and follows the path shown in the graph. So here's our ball being thrown. The x-axis represents time, and the y-axis represents height in feet. Okay, so there's the height. So after 1 second, our ball is about 21 feet, right? After 2 seconds, our ball's about 25, 30, there's 35, so like 33 feet. Okay? So what is the maximum height of the ball? Well, that's the tallest it goes, right? That's our maximum. So we would estimate 25, 30, 35, maybe 36 feet. Make sure you put units. How many seconds did it take to reach the maximum height? Well, here's our maximum height. And it took about, let's estimate, 2.7 seconds. Again, it doesn't have to be perfect, but that's how long it took to reach our maximum height. And you can see that this maximum height, and see, what were we referring to? This is the vertex. Remember that from earlier? So we would say the vertex is 2.736. Okay, the maximum's 36, but where the maximum occurs is 2.7. How long did it take for the ball to land on the ground? Well, the ground is at height 0 down here. So you can see it took about, and I'm estimating again, 5.4 seconds before it hits this ground. Remember, 0 feet. So what is D referring to? This is referring to our x-intercept. An object is launched at 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's height s at time t after launch is h of t equals negative 4.9 t squared plus 19.6 t plus 58.8, where t is in meters. When does the object strike the ground? Okay, so this is just like our last one where we're looking for the x-intercept. So since it's an x-intercept, that means, from our previous chapters, we know y equals 0. So in my equation, we don't have a y, but we have h of t, which is the same thing as y. So we could say 0 equals negative 4.9 t squared plus 19.6 t plus 58.8. What we're going to do is we're going to divide negative 4.9 out of the entire thing. I'm going to divide everything by negative 4.9. Well, 0 divided by 4.9 is 0. This first one, negative 4.9 divided by negative 4.9 is 1. So I get t squared. 19.6 divided by negative 4.9, I need a calculator for that. So negative 4. So minus 4t. And 58.8 divided by negative 4.9 is negative 12. Okay, now I have a quadratic that I could do a little more with. I'm going to factor and solve it. So I want factors of negative 12 that add up to negative 4. The better you get at seeing it, the easier this is, so you don't have to list out all the factors. I know that negative 6 times 2 will give me negative 12, and I also know that negative 6 plus 2 will give me negative 4, so these are my factors. So now I'm going to factor it as t minus 6 and t plus 2, and I'm going to set them both equal to 0 and solve using my zero product property. So t minus 6 equals 0 and t plus 2 equals 0. Let me solve them real quick. Plus 6 plus 6. T equals 6 seconds and minus 2 minus 2. T equals negative 2 seconds. Well, -2 seconds doesn't make any sense. We can't hit the ground by going back in time, so this is what we call an extraneous solution. Okay, it doesn't make sense in the terms of our problem, so 6 seconds is our solution. Okay, it takes 6 seconds to hit the ground.